Well, students, here we are at the end of week 3 of online learning, and here's another screencast with Mr. Swan. So what we're going to do today, we're actually going to finish up the notes for the unit. The climate unit is pretty short, so it really didn't take us very long to get through it. I'll talk about precipitation a little bit today and how that affects climate, and then I'll bring up orographic and rain shadow effect as well. And so, picture of the day. So here we go. On the top right is a little artist rendition, but it's really the bottom left. That is the actual true picture of the day. And what that is what they believe to be the oldest bilaterian that has ever been discovered. It is a bilaterian is a little tiny animal that has symmetrical sides, has a distinct front and back end, and a continuous digestive system that goes and connects those two ends. So really, that is an ancestor to pretty much what all living things are. And it's about over 500 million years old. It is the name for it is Icaria wariota. And it is going to be pretty much your distant relative if this research actually works out. So kind of scary, I guess, if you take a look at that artist rendition of what it is, was like this wormy kind of type creature that really just kind of went through the dirt and soil, looking for organic matter and then just eating it and trying to pull its nutrients out to survive. This is not exactly a new discovery. They've seen these tunnels before, and they've been studying them for about 15 years, but it was only one researcher who noticed that one tunnel had kind of like a little bit of a bump in it, and that's what the picture is in the bottom left-hand corner. And they got some funding from NASA. They were able to do these really neat 3D laser scanners of what that would be, and they're actually able to take a really distinct look at what that organism is. Kind of take a look at the head end and the tail end, and the different kind of grooves of its outline of its body, and that's pretty much it for that. I mean, it's kind of always neat to find a new fossil, even though something is so tiny. But really, it is what makes a good researcher and what makes a good scientist is, as always, and what I've always said before, observation. They've been looking at this for years and years worth of time, and finally it was like someone came up and was like, "What's that?" And then all of a sudden we get this really new cool thing. So we'll talk about the geologic history of animals, and that's going to come up in our next unit. So this will come up again a little bit later on. So kind of neat to see where maybe things all kind of started out as and how they kind of worked up. So over time, our picture of our picture of evolution gets better and better and better, and our idea of what the animal family tree is gets fuller over time as well. The next part, let's go on over to the notes. So we did and kind of left off of the 5 factors that affect climate. We did the first 4. We did latitude when we did elevation. So if you increase your latitude going towards the North and South Pole, you're going to get colder. If you increase your elevation, like going up a mountain, it's going to get colder. If you have some warm ocean currents going past your location, it's going to get warm, and the opposite, it will get colder. And then if you're close to a large body of water, your climate is more moderate, right? So San Francisco, really close to a large body of water, so their winters are not really cold, and their summers are not really as hot, so their range throughout the course of the whole year is relatively small. If you're away from a large body of water, that means that you have the hottest summers and the coldest winters. So your temperature range throughout the course of the year is going to be really really extreme. And now it's time to go to precipitation. Precipitation is greatly going to affect what is the hottest part of the world. And if you were to think about it and you said, what is the hottest part of the world? Usually people would say the equator, right? So it kind of gets the most direct sun rays throughout the entire year. It's like practically forever summer down there. And it would kind of make sense, but it turns out that it's not actually the equator. It's a little bit off of the equator, towards the North Pole and actually South Pole. Sides of those hemispheres. So what's going on is that the rain is going to extremely affect that, because if you have a whole bunch of rain in your area, it's actually going to cool that area down just a little bit. And there are a lot of things that affect rain, and the 2 biggest ones by far is the latitude of the location on Earth, and then the second would be the mountains that are actually around your area. So we'll start with latitude first and how latitude actually affects climate, and then we'll move on to the mountains ones as well. So how that will affect, climate, I really should have said precipitation. So On our world, and I've shown you this picture before, you'll see you have the hemispheres down in the bottom right-hand corner. These spinning kind of circles right here, those are supposed to represent convection cells. And there are 3 major ones per hemisphere on our planet, and they kind of spin. It all kind of really starts here at the equator. And the equator gets a lot of sunlight, it gets a lot of heat, there's a lot of, in theory, there's a lot of water right there, and then that's low pressure, and that low pressure air will then rise, so low density. So as it rises, and that air rises on up, and I'm moving my mouse just like a tiny little bit to kind of show you that, so it gets like here. If you have rising air, eventually that rising air is going to cool until it hits the dew point, which will form clouds, which then will form rain. And so what happens is right here by the equator, you get this really constant band of rain. And it rains there a lot, which actually cools down the area. You continue on with your convection cell. And so you're kind of moving right along. So this air up here, it rains out all over here in this green line. And then it continues on and gets to a point where then the air starts to dry out. It gets a little bit denser, right? And then it eventually starts to sink. And as that sinking air goes down towards the ground, it will eventually start to compress due to adiabatic compression, and will start to heat up. And so then you have a whole bunch of really dry and really hot air right along here in these bands that are colored red. So these high pressure lines right here will be very dry, very hot. The opposite will be here where the rising air, it's a low pressure line where it will start to rain more, and it will start to be just a tinge cooler. So if you want to go to some of the hottest places in the world, you actually wouldn't go to the equator. You would go off of the equator until about 30 degrees north, because that's where you find all the major deserts of the entire world, like the Sahara, the one I have pictured here. And if you continue on, the next time those 2 convection cells meet at 60 degrees north, you'll have the rising air, so you'll get some more rain right over here. This amount of rain at the 60 degrees north is still more than 30 for sure. It is not nearly as much as the equator. So it's still a low pressure band. It still rains, but not as much. And then here, when you go all the way up to the North Pole, that air sinks again, and that creates a high pressure area. So that becomes really dry. And that's one of the reasons why the North and South Pole, it doesn't really precipitate there so much. And so they're actually considered deserts as well. And desert doesn't have to mean hot. It can mean cold. And so that happens to be cold there. So a desert just means not a lot of precipitation, which they definitely do not get. So these bands happen every 30 degrees, just about. So what happens at 0, then 30 degrees north and 30 degrees south, 60 degrees north, 60 degrees south, and then 90 degrees north, and then 90 degrees south. So where are we, and where are you? We are right here about 43 degrees latitude. So we're not exactly on the 60 degrees north, we're getting in theory about the most rain, but we still get a lot because it kind of picks up as you kind of get to closer and closer to that area. So that's why we get some rain here, but not a lot comparatively. And I'm going to go a little bit back to the next one and show you this one. So this map is called the Global Surface Brightness Temperature Scale. And the idea is that it takes pictures of the land, and then it takes a picture of the brightness of an area. So if it's more bright, it should be more clearly distinct. And if it's less so, then it becomes less distinct. So if you take a look at these, you'll see that the Sahara is very well outlined, including parts of the Middle East and India right here. Australia is pretty good. South America's okay-ish, some areas. North America has some, it has Mexico pretty well outlined. The United States is kind of outlined, just a little bit inside. And then as you go up higher, Canada, it's not there as much at all. And so you can kind of see, it really would be, Africa in particular, this solid outline of Africa really should be there for the entire of it, right? It should be totally well outlined in kind of this deep red color, except it's not, right? You have this band right here of this blurry yellow orange stuff going right across the equator, and that's what's interfering with that is rain and precipitation. So there's that band of precipitation that happens right there by the equator, was what we were just talking about a slide ago. This is a way to visualize it. There's one better way, and NASA just released this a little while ago, but I still like it. And this is a map of the weather satellites taking images of precipitation and then modeling over the course of the entire year as they go right around. And I'll play that for you, and you can see, and I'll send you a link for this as well. You can see those bands right? So right there in the middle, right where the equator would be, right? You see this like line of precipitation right here. So it's not perfect. It's not like a straight line. It breaks up, and then the wind currents can kind of throw things into some motion, right, and kind of mess things up. But this is where, if you take a look at this area is the Amazon, right? So the Amazon rainforest. And why is it the rainforest? Well, because it rains there constantly because it's at the equator. Another rainforest over here, the Congo, rains there constantly. So that's why they have like this green section over here in Africa, and it's like that all year long. And then you have more areas over here, lots of rain, so you get like a lot of greenery over there all the time. If you go up above to about 60 degrees north, now you're pushing like this range, you'll see that band of precipitation as well. Not really, as you might notice, not as defined as this one by the equator. It's like a little bit wider. It looks like it's stretched out a little bit more. It's a little bit more sparse. But it still technically counts, and so we keep it. And then down here, like this part of America is about 42 or so degrees in latitude. You'll see that precipitation that's kind of coming here as well, and those lines carry all the way through. So you kind of get this line of green, and then over here about 30 degrees north, right? That's that dry band. That's why there's not really much green there at all. And then you might start to notice, the more you look at this, the exceptions. Right? So if you look at this part over here, like, well, wait a second. We talked about like here should be that dry band, but this doesn't look very dry. And then you look over here and you're like, well, this should be the wet band over in this part of North America, but that doesn't look very green. And that goes into our like next parts, and the Andes kind of throw off some as well. You'd be like, hey, here's a wet band down here, like 60 degrees south, just about. A lot of rain, but yet this part of South America looks pretty brown. So like what's going on there? And that's really the next thing that affects precipitations, which is called the orographic effect. So we just pause this and we'll go back to our notes. Which is orographic effect, rain shadow effect. It's kind of the same name or two different names for the same term. Really, orographic effect is applied for one half of it, and rain shadow is applied for the other half of it. But if you wanted to call it orographic effect for all of it, it's very common to hear that, so that's okay as well. And this slide kind of goes and explains. You can always pause this to go back through and take a read through if you'd like to. But I'm going to go right on over to the diagram, and I'll read everything on this slide. On this slide. So this picture right here on the top left is a picture of New Zealand, where you have the same thing. You should have areas where a whole bunch of rain is going right down through. You should have those precipitation lines should be very, very distinct, but yet it's kind of not. If you take a look at the top half of here, you might notice that it's really dark green on the northwest side of these mountains. And then here on the southeastern side, it's kind of like a lighter green-ish to brown. And the reason for that is because the mountains interfere with how the wind is moving, which then interferes with how the precipitation comes out of the sky. And so we call that the orographic effect. And this diagram here, right here on the bottom, is kind of a little intro to that. I have another one, though, that I'm going to use instead, which is this one. So you have a wind traveling over the ocean, or air traveling over the ocean, and over time it will pick up moisture, and it will hold on to that moisture, and sometimes it rains over the ocean, and then it'll pick up more, and then that process continues on, and eventually it goes over land. And as it goes over land, that air is going to rise in elevation, and it's going to go up and up and up. And so if you take air and it has moisture in it, and then you start to force it up into the sky, it should sound something similar to what we talked about before. It should sound kind of like the adiabatic effect. Right? Or it should sound like, the process that a cloud forms. That if you take moisture and you rise it on up, it's going to be less air pressure up there, right? The higher elevation you go, temperatures are going to get colder. And then due to that adiabatic expansion, you're going to have your parcel of air is going to cool down. And then your parcel of air is going to hit the dew point. And then after that, it's going to start to condensate more. Then evaporation occurs, and then you're going to start to get rain. Or snow, which is also possible. Precipitation in one form or another. So this happens. So the air is rising on up, it's cooling down, and then it is dumping the rain. So that happens all on this one side of this mountain. And then as it continues on, you might get some snow up here. The opposite happens on the other side. The air is now no longer rising, it is sinking. It is compressing back down into the ground as it travels right along. And then that compression is the opposite of expansion. So instead of cooling with expansion, now you're going to get heating. And so that compressed air is going to heat up. It is going to be very, very hot. And then all the rain, though, dumped out over on this left side. And then on the right side, there's really no more rain to be had to be let go on over there. And so this side becomes incredibly dry along with very, very hot. The climate becomes desertish. And so on one side of the mountain, it could actually be really, really like lush forest. And the other side of the mountain, it becomes like desolate. So this happens, and this kind of predicts to a degree, like which side of the mountain are you going to go live on? Probably the left side. So this determines where mountains are placed. Actually determines like sometimes where people have built their cities. So think of like America to the west, like West Coast. There's more population to like the to the west of the Cascades than there would be to the east. And to give you a nice picture of that is this one. So this is an aerial view. You have some Washington State in there. You have a little bit of Oregon as well. And so like if you were going to live here, and this is the Cascades, like right about here, right in the middle, and wind's coming from the west off the ocean, it goes across the ground, it's rising up into the Cascades, like right about here. It's dumping water that entire time, and as it goes right across, then you have like this barren area. So if you want to, settle, think about, hundreds of years ago, and you wanted to farm crops, there's pretty much no choice of where you're going to go. Like you have to kind of go over here if you want to survive. Here, it doesn't really work out. And so when you kind of think about some of these areas, like even into these Bay Area areas, like Washington State, but Seattle, and Seattle is like really famous for its rain. That's because they're really experiencing a whole bunch of wind off the ocean, and you get a whole bunch of orographic effect, right? So a whole bunch of rain over here, and then they're not really getting too much rain shadow, which is over here on the other side. And a nice video for that, and I'll link this for you too in Google Classroom, is this one. It's hard to get a good video of orographic effect. Because it happens over such a large area over a very long period of time. You don't really see it from the ground too much, but every once in a while you can kind of get something very, very close. And here's an example of that. So wind is coming off from the right side of the screen, going to the land, right? So this is coming off of the Pacific, going over to the West Coast, and the wind is coming right here along the side, and then is getting pushed up in elevation by like this island right here. And then you're starting to get your clouds are starting to form right here. So it's actually cold enough that it's actually going to be able to hit the dew point, and you're starting to get that condensation, and you see all these clouds actually starting to form like over here in the distance. And I'll play for that to you just one more time. And so you're seeing the orographic effects, like no clouds. And now over time, I'm just going to skip ahead just a little bit. Now tons and tons of clouds being formed from that. So that's it's air rising, kind of being forced up, and then eventually cooling, hitting the dew point, clouds, and then eventually for Seattle, it will be rain. Another really good one I found, and I'll link this one for you as well. This video is like a little bit longer. This is a time lapse. That's why the trees look so jittery off to the side. Right? Wind is coming from the right side. It's going up the mountain. And then you can see where the clouds are being formed up here, just kind of out of nowhere. So there's like not really clouds anywhere. And then all of a sudden they just start to kind of like appear. Almost kind of like the mountain is like has smoke coming out of it. But that's not smoke. That's orographic effect and like a little bit of a visualization that you can actually see it happening. See, it's like no clouds and then just clouds, just like everywhere. This video goes on for a lot longer, but I'll let you go view it for yourself. And so that's what this is. So going back to one of my last slides of the unit, orographic effect, just a little diagram. Wind comes up, it goes right along the side of the mountain, right? It rains mostly right over there, and snow probably a little bit towards the top if it gets cold enough, and then goes along the outer side, and then that's really, really dry, really hot. So the climate changes. There's names for this as well that you should learn. One's called windward, and the other one's called leeward. Windward means the side that's getting hit by the wind. So if you go outside and the wind's blowing and it hits, right you in the face, that is the windward side. That's part of your face would be the windward side. The other part is called the leeward side, faces where downwind would be, and so that would be like the back. So wherever the side is hitting towards the wind, that's called the windward. And then the opposite of that, where it's kind of going away from, or the downwind of that, would be called the leeward side. And so from these pictures, like this one of my New Zealand, you should be able to tell me which direction the wind is coming from. If you need a second to pause the video, go ahead and do that. And so I need to give you some hints if you need them. There's a lot of greenery here. Not really any green here. So that means the wind must be coming from the northwest. So it's going down, at least in my viewpoint, it's going down like this. From kind of top going, working its way down. I realize the camera might be like mirrored, so I'm not really sure that's 100% going to work out for you. But going from like this top corner over here down towards the middle. If the wind direction somehow changed, which probably won't happen unless the Earth like spins maybe the opposite direction or something like that. But if they would changed and then the wind was coming from like the bottom of the diagram working its way up, the whole climates would reverse. Here would be the desert region, and then here would be where the green is. So for these diagrams, a lot of times, if you even go look on these online, mostly they come from like left to right side. Left to right or right to left doesn't mean anything. It just has to be kind of which side is coming from the ocean and hitting the mountain first. So in this case, for New Zealand, it's coming from the northwest. In this case, my imaginary mountain is coming from the east. If you went back to my other diagram over here, in this case, it's coming from the west. And there had to be an ocean like right over here. There could be an ocean like over there. This could be like a tiny little island. But it's wherever side the wind is coming from first from the ocean, that's the side that's going to have the greenery on it. So that's going to pretty much finish me up for today. I have a little Google form for you guys to go ahead and take a look at. It has just a few questions. I think I timed it to take less than 10 minutes. So this will be a pretty quick one for you as well. And then that's about it. I put these links to these videos in case you want to go take a look at them for yourself. And besides that, I hope you have a really good weekend. And I will see you on Monday. Have a good day, guys. Goodbye.